Good afternoon. Thank you very much for coming. I'm going to give a lecture on integrating building design programs with 4D BIM, which includes a little bit of the history of CAD/CAM and perhaps drawing a link between construction and engineering. Sorry, could you close the door, please? Thanks. And if no one objects, I'll both record this on video and also on an audio file. So I hope that's okay with everyone. So those watching on video, you should be able to see the slides. I'll move it forward a little bit. Thanks. See if that works a little bit better. Yeah, it kind of constrains my movement, but it should be good. Yeah, it should work if I stay more or less right here. Anyhow, thank you all for coming. I'm going to talk today a little bit about some of the BIM basics, what direction BIM is going. And if those of you who've gathered already, BIM is it's a kind of a assemblage of different modules and programs that fit together to produce what should evolve into more of a CAD/CAM system. In other words, a computer-aided design and computer-aided manufacturing system. So the vision for BIM, it hasn't quite been realized yet, is to have an integrated design, communication, modeling, engineering, and then production system. So there's a lot of history of that. And I'll talk about it, where it comes from, and so forth. And mostly to try and put it into perspective, to give a bigger picture of the industry and the field where we're headed, and of course to provide you with some insight into it. Those of you who are studying BIM in more detail, I think you will be familiar with what I'm saying. The other thing I'd like to do is to link it in with the material that we've been delivering on project programs that Silorm and I have been working on together. And this is the idea that the program of a project is actually led by a Gantt chart or the kind of systems that are behind that. And this is nothing more than a rather complex and elaborate calendar. And the thought that this production system could be actually managed through a Gantt chart is something that construction engineers and certainly construction managers have been dreaming about for a long time. So it looks as though there's some realization, and I'll give you my take on how the industry, how the technology has evolved. I'll also make some comments about how I see things in the field. Do I go on site and do I see BIM? 4D BIM in practice, and what is the government's plans for this particular? Our government, the UK government, is pushing BIM as a way to resolve some of the economic and sort of commercial problems behind it in the construction industry, and this is sort of seen as a kind of a silver bullet in order to restore the construction industry to the rightful place in the economic heart of our country, and I have some comments about that as well. Right, so anyhow, that's what I'm going to talk about today. And just to give you one slide that kind of encapsulates this all. This is from Revit's site, I believe. And what it shows is on the same slide a Gantt chart linked in with the model of a building that's being constructed. And the different colors is the dark colors are columns, the slabs are kind of in a beige. And as you work through this, this is actually an animation. As you work through this, you can see the different elements of the building. So it's a great aid in the constructability or the phasing, the design, and a great tool for management. So this is sort of the dream of the 4D BIM, the 4D BIM world, right? So how do we actually get to this point? What's required in order to achieve this level of integration, systems integration? We have quite a way to go, but I'll start sort of picking it apart in a way that in the way that should allow you to be familiar with the systems when you finally see them on site or when you see them in your office. So anyhow, the idea behind the 4D BIM, the real idea behind the 4D BIM is that changes in the structure of the building, so you're working on a design and say you've decided to change a concrete frame to a steel frame. Seems like a fairly minor change, but actually it has a great deal of impact on the program. Concrete, you build the forms up and you pour the concrete. Steelwork you have to pre-order, it has to be custom designed and fit, it has to go through a whole series of it. So the whole scheduling it'll be off-put by it. But the idea behind the 4D BIM is with a few clicks of the mouse, perhaps more than a few, but you can actually change the structure and it would realize that this is a more lengthy process to get a steel frame going. So anyhow, materials choice, changing in the cladding type, changing in the kind of windows that you're using, using cassettes rather than installed windows. That thing would have big implications. There was one issue going on now in the industry is that buildings over 18 meters are not allowed to be made out of wood anymore. And that's because of the latest regulation change due to the Grenfell fire. So all of a sudden, this has happened very suddenly, and all of a sudden, on the drawing board of architects and designers all over the country are wooden buildings of 23 meters plus, and they're going to have to rebuild them in concrete, redesign them in concrete or steel. So we've had an abrupt step change in the regulations that is going to cause a redesign. And I'm sure everyone's pulling their hairs out, people who are investing heavily in this CLT and other kind of wood design frames. So ideally in that sort of situation, the vision of 4D BIM would be that you could make these changes fairly quickly and easily. I'm sure it's a lot more fraught than that, mainly because the 4D BIM hasn't fully been. So what lays ahead of this? You know, how does this fit in? So 4D BIM, if you know, is a nomenclature for 3D being the normal dimensions X, Y, and Z that we know about, and the fourth being the time, the program itself. Now, of course, there's 5D BIM. If you weren't satisfied with 4D, that includes costs, so that you'll be able to click on an element, change the material type, and derive the costs automatically. And there are plenty of people working on this. As far as I know, there's no functioning commercial system that's working, that's available to buy. So there are probably people who have in-house models and are working on it, but nothing. 60 extends it even further. It's cost, but it also includes the operations of the building. The idea that you'd be able to fully test the functioning of the building or fully use the BIM model as a facilities manager. This is a great dream of architects and engineers. They spend so much time working on constructing a building and on designing it and piecing it all together, and pretty much all the effort that goes into it all the design effort is sort of lost. I mean, it manifests itself in a solid object, which is good, but it can't. The model itself loses its value as soon as the building is actually commissioned, and this is a shame because the model itself has intrinsic value that could be sustained if the model was to work in use. I'll give you an example. There's some issues with heating and ventilation in this building. It'd be very nice to go back to the BIM model, run some tests, investigate some things, and come up with a solution. Maybe it would be installing an additional vent, or increasing the size of the vent, or changing the way the intake louvers are structured. A cheap, simple, easy fix to correct some of these shortcomings. And of course, if we did have an online model, you could do it all on your desktop. You wouldn't have to go creaking around the vent shafts and unscrewing things. You could run a series of tests, You can try out a few things, see which one is the most energy efficient, which is the lowest cost for retrofitting. And you can go ahead and launch this thing, and if your BIM model is reasonably good, then the actual reality will reflect that. I'll just talk a little bit about the history of CAD/CAM, which really has an amazing, sort of history to it. It's the history of CAD/CAM. I read about it just recently, and it goes right back to the beginning of the computer revolution in the 60s, when the government was desperate to try and, when the US government in this case, was desperate to try and computerize their systems, mainly the military system. But the real place was Lincoln Labs and MIT during the 60s and 70s, when they came up with, first they came up with this idea that you could have a computer-aided design package that you could launch on your computer. You could do engineering on it, and you could also do engineering and design. They were all sort of separate. The designer would draw the sketches, and the engineer would do the calculations. But the idea behind combining these on a computer was one of the early dreams of the computer age. Right, but the real driver behind the adoption of BIM in this country is the government. And mostly it has been driven by a series of influential reports on the nature, on the state of the British construction industry. Most notably the '98 report, Rethinking Construction, known as the Egan Report. Now it's not completely, there's a lot of sort of controversy on this, but one thing that is clear is that Egan pushed the adoption of new technology in order to resolve some of the commercial shortcomings of the industry. So the construction industry is, depending on how you look at it, is a significant portion of the entire British economy. I mean, the building, the design, build, construction, dismantling, refurbishment of built assets represents 30 or 40% of the whole turnover of the country. And if you start comparing it with other industries, you realize that as it stacks against terms of profitability, productivity, the amount of value that's added by a day's labor is much lower than other industries, pharmaceutical, financial services. And that's because, but there's a number of reasons why that's the case. There's a lot of redundancy and repetition in the industry. You put out the tender and 5 people have to put a bid together, 6 people have to put a bid, 6 groups, you're talking about redundancy of labor. And the buildings themselves, it's a very chaotic process, or it's seen as a chaotic process, sort of mishmash of things. So there's lots of reasons, and many people who are studying very closely this, and just to try and get to peace. The latest report, the latest useful report that I read was by McKinsey, and it was on it's another Rethinking Construction, and it is on the reading around the subject folder on Moodle, so you can find that report and read it, and that's all about productivity growth. And we've entered just the last few years, the productivity of British industry has plummeted. No one quite knows why. It might have to do with political activity or political movements like Brexit, but it was growing reasonably well. But just in the last 2 years, the productivity being the amount of profits generated from a day's labor, average day's labor, and it's quite alarming. It has multiple. There's some real economic benefits to having high productivity growth. Right. Right. So the other thing I think that has sparked or encouraged people is the fact that other industries seem to manage CAD/CAM really well. So the airline industry is really good at designing, producing, manufacturing, testing, doing test flights on the computer. So they have a fully the big airline manufacturers don't produce prototypes anymore. They simply start production. It seems startling that you would not have a prototype plane, but they don't. They actually design it on the computer. So this is going back, and this is the sort of machinery that was around when I was starting out my engineering course. And we even had a few of these things around, nothing quite so big. But this was just the controller, that's just kind of the keypad. This is part of this is a massive air conditioning unit to cool down, they had not a microprocessor, but a processor. And it was all driving through this gigantic bus of cables. This is a combined lathe and milling machine. So it's a pretty fancy piece of machine tool. And then there's this rotor right here holds multiple tool heads. So you can, as it rotates, you can shift it around. And this is a belt that, anyhow, these things were absolute monsters. And a modern version of this would, a modern version doing exactly the same thing would occupy only this space right here. So it wouldn't include any of this extraneous stuff. And you would program it on the desktop with the PC set up. But this is sort of the early days of the CNC. In the CNCs, the operator would actually be given a set of drawings. He would take measurements. He would bolt the part in exactly in a jig in exactly the same place, and he would run a sequence. He would have to do it. He'd have to run a trial sequence just to make sure that the tool heads don't go smashing into the bits or anything like that, or the holders. And anyhow, this is how this worked. It was a sequence of movements that you would program step by step. So it wasn't as we know it, but this is sort of how it started. This was the computer-aided manufacturing. And of course, this is applicable, this sort of core idea of a computer-aided design and manufacturing system led to lots of other software packages, of which through these you can pull out some of the aspects of BIM that are useful. So CAD is the idea that you have a computer-aided design. Computer-aided engineering is a step beyond that. We're able to test the vibration response of a system, or the strength, or how the system reacts under wind loads or snow loads. You have the CAM system, which is the origins are in the CNC machinery, where you have a computer-led or computer-controlled machining setup and production system. You have process planning, where you set up strings or whole production lines based on computer modeling or computer simulation. Quality assurances, where you have a separate system in place that monitors quality from start to finish, so that you can understand the flow of quality, how quality affects the flow of production. Production planning and control, so that you can have real-time ordering of equipment and supply chain management. And then, of course, ERP. ERP right now is this Enterprise Resource Planning, or ERM it's called, Enterprise Resource Management. It's the biggest software company in Europe is the main product, or the main product of that. That's SAP. Most of you will be familiar with it, but Oracle does something similar. And so this is one of the leading uses. And the idea behind ERPs is that you buy a modular system where you can computerize your entire business. So you can put your entire business online. And this is an awful lot of what Amazon is encroaching into. They have worked through this ERP system really pretty well. Now I drew this little schematic just to kind of show kind of complexity of the 4D BIM system in construction. And I'll explain it from sort of the center outward. So what we have is a shared model, in other words, a computer version of the building that we're building. And as you can quite well imagine, the normal disciplines, the three core disciplines, which would be the structural part, how this building is held up off the ground, the architectural bits, which is the kind of overall design, the appearance, and the placing of the columns and stairwells and so forth, and then the MEP, which is sort of the internal guts, the workings. And of course, they have to share this model. So that when one part changes something, the other ones see it, the other ones know about it. And this sharing of the model is understandably quite complex, and is there's actually a British standard that goes along with it, and an international standard as well. In other words, how is this sharing taking place? Now, they haven't quite worked it out, as far as I can tell, up to the final details for the fully shared model. So, so there are elements in place that would allow a fully shared 4D BIM system in place, but the international standards, as far as I understand right now, aren't fully implemented. But anyhow, the architectural model itself would be receiving input from sub-models. I'll give you an example of that. The facade of this building was designed and installed and built by an Italian company called Folchi. Actually a really nice company. And they sent a team that were here for a couple of years, really. They have an office here in the UK. And all of their layout is done using a very elegant CAD system, which they bought and they tailored to their particular use, their facade use. So they can actually do quite a bit of engineering on their facade. They can test the wind load, they can integrate it with the structural frame, so they make sure they hang the facade off the right connecting points. They can model things such as bird strikes or wind circulation through around their facade. And some of the angles, all buildings have some quirkiness. Some of the angles and so forth can be worked out with quite fine precision in terms of their modeling. And of course, they want to integrate this in with the architectural model, the frame itself, the floor spacing, the location of the stairwells and ventilation stuff, and access points that might not be visible to the public. And so anyhow, this company would want to integrate their computerized system in with the architectural model. And the same thing goes with the MEP model. There will be, for instance, Havoc. I'm sorry?
Havoc. Is circulation.
Yeah, exactly. HVAC, yeah, exactly. And other things like biological testing, is this particular ventilation system susceptible to Legionella's disease? If it has pooling or fire escape and emergency access and ingress. All of these different sub-models, it would be lovely if they could actually integrate in with the shared BIM model. So someone could propose something, someone could do a sort of a quick, rapid evacuation. It's a great thing to know. How long would it take if we sound an alarm to evacuate this building if it was fully filled with students? How long are the stairwells big enough? And there are actually software models that will allow you to do this. You fill a building up with people, you blow up a corner of it, and you see how quickly people can, you computerize this system so you can test, if you blow up 2 corners, is it still evacuable? Or so you can actually simulate disasters and see. And of course, it'd be really nice to be able to integrate these findings fully so that you can start doing testing really early on, testing on the integrity or the sort of usefulness of the building. Structural models. I know that there was a lot of toing and froing about the structure of this building when it was built, because it is it's a good example to use because it is a composite building. Some elements were poured in situ. I think these were poured in situ, these walls. but the ceiling slabs weren't. And I think the columns were poured as well. You can just see some of it. So it isn't a purely built-in-place structure. There was a great deal of off-site going on. And anyhow, it's nice to have it'd be nice to think that the whole kit and caboodle could be recreated on the desktop, and you could spend some time modeling it, testing it, seeing if there are cheaper methods, seeing if there are better production systems, if the phasing could be different, if the design needs to be altered to accept larger number of people, or working at night you need different sort of energy requirements. So anyhow, this is what it's like. But the idea behind the dream behind these 4D models is everyone can kind of collaborate in some kind of positive way. Architects designing, cladding people, M&E, lift contractors. Lifts are a big deal now. Well, we have one lift in this building. We're going against the use of lifts. Everyone should use the stairs. But it'd be nice to model whether that's really, will it really work? Will we have access to all of the building for people in wheelchairs, or can we get people out who are sick? Right. But anyhow, just to say that this BIM, the idea behind this fully integrated, functioning system isn't quite there yet. And I think perhaps by my discussion you'll understand why it isn't, because it's the sheer complexity or the sheer possibilities of doing modeling. However, if we were to get anywhere near the airline industry or the automotive industry, is another one that they design things almost entirely on a computer these days. There isn't much prototyping going on. I mean, they might make a mock-up for a car show or something like that, but that's just for marketing purposes, really. When it actually comes to the real production aspects of it, they just computerize it and then start production. I mean, if we could approach that, if we could approach the automotive, the aerospace industry, other toy manufacturing, things like that, I think we'd be doing really, really quite well. But we are lagging in that sense. Right? But if it ever does get implemented, and there certainly is a big drive to do it, it would certainly has the potential to opening up a lot of unexperienced or unresolved or unfound profits in the industry, which is what we all really want in the end. We want a more profitable, slightly less contentious, a little bit less depending on communication and more depending on the technology and systems behind it. So I'll talk a little bit about PAS. This is the framework or the standard for establishing the conventions about sharing models in a BIM system. And PAS 1192 is an evolving set of standards. So they're working now on the next generation of industrial standards in order to allow BIM systems to collaborate with each other, so that you can use one model after the next, and also some ways to ensure that intellectual property in the models is conserved. So architects are very fussy about their intellectual property. If they do a drawing of a building and a concept and so forth, they want to make sure that someone just doesn't do a cut and paste, and next thing you know, there's another building just looking just like it somewhere else, and then the person hasn't gone the extensive route of designing it from the ground up, rather than he's just been very good at transferring files. And so they're very concerned. And of course, if you have a shared model, it means different components of that model has actually been done by other people. So the structural engineers are always thinking, well, this building is really my baby, my brainchild. I was the only one who could thought about this great cantilever, or this huge clear space that we have, and these lovely corridors, and it was because of my engineering prowess. So there is a little bit of tension, I guess, or a little unresolved. There's unresolved issues that might take a while to work out for this in the development of the PAS 1192. But by all means, I think you should become familiar. You should read these documents. Has anyone ever mentioned? Have they been mentioned before? They're quite core actually now in the development of BIM. So they're important, and they are on Moodle. You can find them easily. They're all free to download. Right, the different phases: 1192.3, 1192.4. So they're working on new versions of this as we speak. And I sat in on one of the meetings. Standards is a really dull. I mean, I can understand why it's taking so long, because they have to work out in a very refined and kind of simplistic way how to ensure that everyone's doing things in a similar fashion, identical fashion, I should say. So this idea behind this common data environment, it sounds like a wonderful idea, like a big giant playpen. But as just mentioned before, it's fraught with ownership issues and other sorts of problems. There's also security things, you're storing things on the cloud, which makes a lot of sense, but some of these models are monstrous. So you build up expenses and costs because you're using cloud-based storage and cloud systems. And there's some connectivity issues, redundancy. So there's a lot of things to work through. I'll skip over this, but this is from the 1192. This is the top common data environment. This is from the 207. This shows the workflow about how various contributors submit tentative models or submit work in progress. And then that work in progress, so it's submitted over here, and that work in progress goes through an approval process before it's actually allowed to enter, to be integrated into the shared model. So here's the shared model here, and there's a approval process going in this direction, and then the accepted design goes out here that's also verified and archived. So there's actually a standard method to follow when actually you're dealing with a shared model, and it's described by this 1192 common data environment. Right. I'm going to skip that slide. I'll skip this slide. So one issue is clash detection, when you go off and if you're involved in the design phases, it's quite common that two engineers or two teams working independently will come up with systems that intersect with each other, and they don't. It's quite hard to detect in the model. It's quite hard to detect on drawings as well. And often you go visit sites and there's a beam with a hole cut in it. I've been on so many construction sites where they have these lovely steel beams and they're piercing holes. So some poor guy with a drill, with a steel drill, like for the bathroom drain or something like that. It's just the idea, the dream is somehow that the clash detection can be reduced and avoided with the introduction of BIM, and it's through the implementation, the use of this PAS 1192 that prescribes how this is actually done and managed. So they actually go through crash detection episodes as a crash detection specialist that goes through the BIM model and detect if there's any things. There's issues with not only with three-dimensional space, but clash detection when it comes to programming and the time element of it. Should you install the stairwell first before you build the building around it, or should you leave a hole in the roof so you can drop the stairwell down? And this is particularly relevant when it comes to modular construction, which everyone seems to be doing these days. So, I'll talk a little bit about a data job. I mentioned it earlier. This actually data job itself would be the archiving and the production data set. And the PS 792 specifies this and describes how it's done and what the security issues are. And of course we now have all this wonderful cloud computing everywhere, where we have massive storage available at a cost. I'll skip over a few of these things. I'll talk about the government soft landings because it has driven a new business area in construction, and has actually led to a lot of new work. And the idea behind the soft landings is the contractor, rather than disappearing, handing over the key and disappearing, the contractor sticks around and waits for the building to be commissioned, sometimes up to a year. There are lots of advantages for doing this. First of all, it can be included in the initial contract. And usually what's happened is they withhold final payment for an asset. They withhold until everything checks out. Well, that's not very nice for the contractor, because they're waiting and waiting and waiting to get paid. Everyone's using the building, and you're not paid. You wouldn't do that if you bought a car or a yacht or something. You would pay for it, you would get in it. And the idea of withholding payment is really objectionable. And so the idea behind the soft landing is that you would reduce the need for that. You would actually build it into the contract that you would keep an engineer on site afterwards. And of course, there's a kind of a technological aspect to this as well. I started out this discussion by talking about how nice it would be if we were able to retain the value of the BIM model through the design, development, construction, and then actually use it in use to analyze a building or to manage a building. And this particular soft landings is sort of what initiated, what has promoted this. And I'm also glad to say that the government has actually stuck with this principle. It's included in the recent reports. So BIM has a role in this, and there are economic and technical reasons. There's a technical solution as well, if we just stick with BIM and make sure it works. I'm going to skip this. Instrumentation class is an object-based format. These are all the sort of things that fall out of the requirements for a comprehensive and coherent standard so that everyone can use it. And these IFC classes, when you start to computerize a building, you have to start to codify the components. And if you look through the IFC classes, there's things like floor slabs, window systems, stairwell design, all these sorts of things. And these are all codified in a way that you can easily put them on a computer. So this is more about the innovation. This division is the interoperability. I think I'm gonna skip over this slide a little bit. I'm going to talk about the different BIM levels and what they actually mean. Has anyone read up on this? Has anyone from you've heard about them? Well, this came out of the government's reports, and out of the 1192, the standard. And this idea, the government has such a overwhelming input and influence into the industry that it seemed reasonable that they should insist upon the next generation of design and construction systems. And they put together what they call levels. Now there's an awful lot of debate about these because, which I'll talk about later. Now almost everyone in this class will have seen this diagram, will be familiar with it. And the idea behind it is CAD, which I've mentioned at the very early, which has been around since the 60s and 70s. Sort of this idea of a design, you can do a design on a computer. The idea behind that is that it would evolve into first 2D and then 3D BIM. 2D BIM being the use of computer-aided design to work through without the program involved, but the idea that you have centrally generated computer-based design drawings. And there's a set of the BS 1192-2 of 2007 and a set of standards for describing building components. And the idea behind this is this would actually be required by law in order to apply for government contracts. So right now we're somewhere in here. We're still at level 1. So if you're applying for a government contract, you have to show that you have a BIM system in place and you're able to do 3D design. But we're not at the point now where we're sharing models or we're really fully integrated. And we're certainly not anywhere near level 2, which would include 4D BIM. Level 3 BIM, which is this fully integrated shared model, timing, programming, costing, everything included in the whole bundle. We're a long way off. And because of these government kind of deadlines, everyone gets worked up about it because it could mean that they might lose work if they didn't get fully up to scratch. So this talk, I just read in the paper this week that they might delay the implementation. So this implementation horizon gets moved back further and further. I don't know. I'm not fully convinced that a government-forced system is always the best, a sort of top-down system. It's not necessarily the best way to go. It's what we have to deal with in the industry, and the government is entitled to it, I guess, because they have so much sway in the industry. They're the ones who are pumping in so much money into the construction industry.
So how far, George, has the contractors using the BIM?
Well, for government contracts, they should be.
Yeah, it's mandatory for government, but if you were a private client, let's say, for example, if you were building a stadium, are they ahead in UK with BIM or?
No. If you're building a stadium, it's a private contractor. You're not, as far as I understand, you're not obligated to use BIM. It may be that the client wants it for whatever purposes. If they might have funding depending or something like that. And of course, they would want to encourage the use of the latest technology. You know, they would probably, if they're building a big structure like a stadium, they probably would expect it from their contractor and from their architect. Would certainly be using CAD. Yeah, CAD. No, they wouldn't be in level 3. They would be level 3 is just in the lab right now. Even parts of level 2 haven't been fully worked out yet. So it's something for you guys to worry about and think about and work on.
Yeah, you know, I was on a career fair, and a lot of people are not like working on BIM now because they're not on the,
as well, yeah.
yeah, so they're not working for public things.
So what do you see that as, a threat or opportunity?
What? To work on BIM?
Yes.
I work on BIM, and that's like it helps a lot. Like I've already seen a lot of effects and benefits of using it. Even before and during the site. So, yeah.
What's your?
Great. It's very good to hear positive from students who are actually involved with, who are actually working in the field.
Mm-hmm.
I have heard the same thing. People who are actually working with it, engage with it, works quite well. But it's expensive and typical. It's a cost. It's a knowledge base. It's expensive to hire. I mean, I hope it's expensive to hire people.
I
hope they're paying you a lot.
I have these two environments as well, because in Brazil it's like really like under development and all this stuff. So we don't have people that model on 3D.
Mm-hmm.
So for example, on my company, we were like modeling some things to help us on the site. For example, I was one of the modelers sometimes, and I went to Germany. They're like receiving all the models, so they're working on it, and here they are more developing on that in some cases.
That's not surprising. I mean, Germany is. It would make sense because Germany has, as a leading manufacturing industry, they would have lots of experience, lots of people they could hire.
Here is more developed than that.
Because of the.
Yeah, in Germany is less developed than here.
Britain. That's interesting. I have a feeling it might be to do.
Yeah, it was for me too. I just got this when
You think we're back? You think we're backward here? I think no. The reason is probably to do with the BIM levels and the government push.
Yeah, sure.
And the fact that the government's putting their foot down, and the fact that you know, the Germans they make money out of it. We don't make as much money out of it. The frustrating thing is we just don't make as much money out of it than they do.
And they
you know?
have like
The profit
long
margins.
contracts and process, so it's like you spend a lot of time on the site there, it's fine.
They train more engineers in Germany,
Yeah.
and in Britain they train more sort of financial managers. Unfortunately, it's true. Yeah.
No,
And they have a technician's route that we don't really have anymore.
They have-
Yeah, the educational system is different.
They
They have
have
a
like a lot of departments inside a site.
And they have the
you have to pass on the process with each other and all this stuff.
interesting. You could write a
just
thesis.
before you continue,
You
are
could-
these slides on Moodle?
Yeah, they should be. Oh, I'll put them on. I'll make sure those.
Just let us know when you put them.
Yeah, sure.
The other thing,
Right.
just a quick one, George. You know, with BIM and construction, and such a big thing, from a contractor's perspective, because that's where my ambitions are. What I've seen is, what I've learned over the last 4 weeks in university, and I'm sorry I might be hijacking this country. The guy who's going to build a building, his role's shrunk, and you've all this major ITK superseding a small building. All right?
Mhm.
And we all know very well that there is a huge shortage of the tradesmen. Big shortage, you know, and they're meaning, you know, a plumber gets paid 60 grand in London. Now, I'm trying to figure this out, because that's where my ambition is. Can BIM, when I employ 20 different subcontractors on the site, can I actually give them tablets and tell them that's their job?
It's a good.
Reach that.
It's a great question, but can you hold it until the very end of the session, and I'll shut, and we can spend more time on it. I think it's an excellent question. Can you actually use it in a practical sense? One would hope so, but let's talk about it more detail. I wanted to just give the different. I wanted to finish up in just a few minutes, and I just wanted to talk about the different levels and sort of where we're at. I mentioned it sort of briefly, but level 0 is sort of no collaboration, 2D CAD drafting only, output distribution via paper, via electronic mixture mode. This is probably sort of where the standard is in the industry right now, I would guess, sort of BIM level. This is maybe the more sophisticated job, level 1, where you have a mixture of 3D CADs for construction work, 2D working for drafting. CAD, you know, actually the CAD standards are up to the 1192, 2007. There's electric sharing of data, you know, they have a shared model somewhere that collaborators are working remotely. There might be emailing stuff or uploading things from Dropboxes and so forth. But the real electronic collaboration, you know, on a real live model, probably not really happening yet. Level 2 is something that we're all sort of waiting for, and this is where, you know, real